Warm greetings to all of you. This is Kavita Saxena explaining Chapter 9 Solar Radiation, Heat Balance and Temperature from Class 11th Geography textbook Fundamentals of Physical Geography. In the previous lesson, that is Chapter 8, we have studied that the air surrounding the Earth is called the atmosphere. The atmosphere is made up of different types of gases, water vapor and dust particles. Atmosphere is essential for survival of plant and animal life. They also require optimum temperature to keep themselves warm and grow. Have you ever thought what is the source of heat and energy received on the surface of the Earth? Why does Earth's surface get warm during the day and cool down during the night? Let us find answers to all these questions and other related questions in this lesson. The main objectives of this chapter are: after studying this module, you will be able to explain the importance of insolation and establish relationship between angle of incidence of sun's rays and the intensity of heat received from them at a place. Explain the concept of equinox and solstice, and can explain the different processes involved in heating and cooling of the atmosphere: conduction, convection, radiation and advection. As you know, the sun is the primary source of energy on the Earth. This energy is radiated in all directions into space through short waves. This is known as solar radiation. Only 2 billions of this energy is radiated by the sun, of the total solar radiation which reaches the Earth's surface. This small proportion of solar radiation is of great importance as it is the only major source of energy on the Earth for most of the physical and biological phenomena. Incoming solar radiation through short waves is termed as insolation. The amount of insolation received on the Earth's surface is far less than that is radiated from the sun because of the small size of the Earth and its distance from the sun. Moreover, water vapor, dust particles, ozone and other gases present in the atmosphere absorb a small amount of insolation. The solar output received at the top of the atmosphere varies slightly in a year due to the variations in the distance between the Earth and the sun. During its revolution around the sun, the Earth is farthest from the sun on 4th July, that is about 152 million kilometers, and this position of the Earth is called aphelion. On 3rd January, the Earth is nearest to the sun, that is about 147 million kilometers. This position is called perihelion. Now we will talk about variability of insolation at the surface of the Earth. The amount and the intensity of insolation vary during a day, in a season and in a year. It's not uniform everywhere. It varies from place to place and from time to time. Factors influencing insolation are: number 1, the rotation of Earth on its axis. The fact that the Earth's axis makes an angle of 66.5 degrees with the plane of its orbit round the sun has a greater influence on the amount of insolation received at different altitudes. It's clear from the figure shown. The angle of inclination of the sun's rays. Since the Earth is round, the sun's rays strike the surface at different angles at different places. It influences the insolation in 2 ways. First, when the sun is almost overhead, the rays of the sun are vertical. They are concentrated in a smaller area, giving more amount of insolation at that place. And if the sun's rays are oblique, angle of incidence is small and the sun's rays have to heat up a greater area, resulting in less amount of insolation received there. Moreover, the slant rays are required to pass through greater depth of the atmosphere, resulting in more absorption, scattering and diffusion. The third point is the length of the day. Duration of the day varies from place to place and season to season. It decides the amount of insolation received on the Earth's surface. The longer the duration of the day, the greater is the amount of insolation received. Conversely, shorter the duration of the day leads to the receipt of less insolation. As the Earth orbits around the sun in an elliptical path, its tilted axis results in the sunlight reaching the Earth's surface at various angles. This is the reason why the length of days and nights vary and are not same anywhere in the world. The solstices and equinoxes signal the changing of the seasons on Earth, Actually, a solstice and an equinox are the sort of opposites. What is equinox? Equinox refers to a day with an equal duration of day and night. We have two equinoxes in a year, which are spring equinox on March 20th, autumnal equinox on September 22nd. What is solstice? On the other hand, solstice refers to a day with either the longest day or the shortest. The two solstices in a year are winter solstice on December 22 and summer solstice on June 21. The next point which influences the insolation is the transparency of the atmosphere. Transparency of the atmosphere also determines the amount of insolation reaching the Earth's surface. The transparency depends upon the cloud cover, its thickness, dust particles and water vapor as they reflect, absorb or transmit insolation. Thick clouds hinder the insolation to reach the earth, while clear sky helps it to reach the surface. Water vapor absorb insolation, resulting in less amount of insolation reaching the surface. Next point, the configuration of land in terms of its aspect. Aspect can have a strong influence on temperature. This is because of the angle of the sun in the northern and southern hemispheres, which is less than 90 degrees or directly overhead. In the northern hemisphere, the north side of slopes is often shaded, while the southern side receives more solar radiation for a given surface area. Insolation because the slope is tilted towards the sun and isn't shaded directly by the earth itself. Similarly, in the northern hemisphere, a south-facing slope is more open to sunlight and warm winds, and it will generally be warmer and drier due to high levels of evapotranspiration than a north-facing slope. The incoming solar radiation is not fully able to reach the Earth's surface. Why? The atmosphere is largely transparent to short-wave solar radiation. The incoming solar radiation passes through the atmosphere before striking the Earth's surface. Within the troposphere, water vapor, ozone, and other gases absorb much of the near-infrared radiation. Very small suspended particles in the troposphere scatter visible spectrum both to the space and towards the Earth's surface. This process adds color to the sky. The red color of the rising and the setting sun and the blue color of the sky are the result of scattering of light within the atmosphere. The important topic now is heating and cooling of the atmosphere. Sun is the ultimate source of atmospheric heat and energy, but its effect is not direct. For example, as we climb a mountain or ascend in the atmosphere, temperature becomes steadily lower rather than higher, as we might expect. This is because the mechanism of heating the atmosphere is not simple. There are 4 heating processes directly responsible for heating the atmosphere. They are radiation, conduction, convection and advection. Now we will talk about radiation. Radiation is the process by which solar energy reaches the earth and the earth loses energy to outer space. When the source of heat transmits heat directly to an object through heat waves, it is known as radiation process. In this process, heat travels through the empty space. The vast amount of heat energy coming to and leaving the earth is in the form of radiation. The following facts about radiation are worth noting. All objects, whether hot or cold, emit radiant energy continuously. Hotter objects radiate more energy per unit area than colder objects. Temperature of an object determines the wavelength of radiation. Temperature and wavelength are inversely related. Hotter the object, shorter is the wavelength of the wave. Now, insolation reaches the Earth's surface in short waves and heat is radiated from the Earth in long waves. You will be amused to know that the atmosphere is transparent to short waves and opaque to long waves. Hence, energy leaving the Earth's surface, that is terrestrial radiation, heats up the atmosphere more than the incoming solar radiation, that is insolation. Now, we'll talk about conduction. What is conduction? The air in getting in touch with the land gets heated gradually and the higher layers in contact with the lower layers also get heated. This process is called conduction. Conduction takes place when two bodies of uneven temperature are in contact with one another. There is a flow of energy from the warmer to the cooler body. The transfer of heat continues until both the bodies attain the similar temperature or the contact is broken. Conduction is vital in heating the lower layers of the atmosphere. Now, the third process of heating and cooling the atmosphere, that's convection. The air in contact with the earth rises vertically on heating in the form of currents and further transmits the heat of the atmosphere. This process of vertical heating of the atmosphere is known as convection. The convective transfer of energy is confined only to the troposphere. The heating of the air leads to its expansion, its density decreases, and it moves upwards. Continuous ascent of heated air creates vacuum in the lower layers of the atmosphere. As a consequence, cooler air comes down to fill the vacuum, leading to convection. The cyclic movement associated with the convectional process in the atmosphere transfer heat from the lower layer to the upper layer and heat up the atmosphere. Now we will talk about the fourth process, advection. The transfer of heat through horizontal movement of air is called advection. Horizontal movement of the air is relatively more important than the vertical movement. The temperature of a place will rise if it is lying on the path of winds coming from the warmer regions. The temperature will fall if the place lies on the path of the winds blowing from cold regions. In middle latitudes, most of the diurnal variations in daily weather are caused by advection alone. In tropical regions, you must have noticed, particularly in northern India, during summer season, local winds called Lu is the outcome of the advection process. What is Lu? The Lu is a strong, dusty, gusty, hot and dry summer wind which is especially strong in the months of May and June. Due to its very high temperatures, exposure to it often leads to fatal heat strokes. We have learned new terms such as insolation, which is the incoming solar radiation, the angle of incidence, the angle formed by the sun's rays with the tangent of the earth's circle at a point. Visible spectrum. It is the portion of electromagnetic spectrum that is visible to the human eyes. Electromagnetic radiation in this range of wavelength is called visible light or simply light. Equinox. The word equinox actually comes from a Latin term meaning equal light. It is the time of the year when the sun is nearest to the equatorial plane, giving equal lengths of day and night. And lastly, solstice. This word has been derived from a Latin word solstitium. It contains two Latin language morphemes, sol meaning sun and stitium meaning stoppage. Therefore, it means sun standstill. So, it's the time of the year when the sun is farthest from the equatorial plane, resulting in long nights and days. After finishing off this part 1, I would like you to evaluate yourself. I hope you can answer these questions well. So, there is an MCQ given over here where you have to choose the correct option. Insolation comes to the Earth's surface in short waves, long waves, both of them, none of them. And I hope you are able to answer it correctly. Atmosphere is heated by insolation, heat radiation from the earth, both of them, none of them. The third one, even after the sunset, the air near the earth's surface continues to receive heat by insolation, terrestrial radiation, conduction or convection. Now, there are 3 markers. Name the processes through which heating and cooling of atmosphere takes place. And the last question, Discuss any three factors influencing the amount of insolation received at a place. So, this is all in this part 1. In the next part, we are going to learn about what is terrestrial radiation, the heat budget of the planet Earth, albedo of the Earth, and latitudinal variation in net radiation balance. Thank you.